Alright guys, I wanted to take a second and talk about different types of voltages. The main types that we will be talking about in the next two videos, let's say, are going to be AC and DC. And those are going to be AC stands for alternating current, DC stands for direct current. So we're going to go ahead and we're going to talk about this sine wave right here, and we're going to kind of talk about AC. In the next video I'm going to talk about DC. I'm going to explain why AC is so good in this video, and in the next video why DC is so good, maybe what you might use them for, things like that. So let's go ahead and let's jump in and let's talk about alternating current first. Why would you want alternating current over DC? And in the next video I'll talk about DC. Well, the main reason that I think that AC is so great is that you can actually transmit it over long distances. So let's say you have a power plant that's in Wyoming, you could be powering houses that are in Sandy or even in Tooele. Don't quote me on that, I don't know which power plant actually runs Tooele. But it could be going a long distances, it can go hundreds of miles in those power lines. What happens with DC is it actually has what they call a voltage drop. As it's moving along, you know, that wire, it actually drops its voltage. So you might start with 100 volts and you might end with 50 volts depending on how long that run is. So what they'll do is they use AC. AC just can handle that, almost no voltage drop at all over long distances. Another thing is it can actually raise it up quite high and then bring it back down using transformers. We've talked about that a little bit. We're going to talk about that a little bit more. But transformers are only used with DC voltage because they're actually creating that alternating voltage back and forth, which causes those magnetic flux lines to actually induce voltage in a transformer. Talk about that a little later. So what we're going to do right now is I want to talk about this sine wave. I do want to explain that we are mostly going to be talking about 120 volts. It might be 110 if you took your multimeter and you tested a plug or an outlet or even a light inside your house. It will be 110 or 120 volts. It's not always perfect, especially in like an older house. You're going to see a lot more 110 volts. Newer houses are going to be at that 120. Now, that is not the only type of voltage that is out there in the DC range. You're going to have 240, you're going to have 277, you're going to have and 480, okay? Now that's going to get talking about, to get into those other voltages, we're going to be talking more about different phases. So right now, a 120 volt circuit is going to be a single phase, meaning there's only one electrical wave moving through that wire, or moving through, it'll be multiple wires when you get to different phases or multiple phases, okay? But just know that we're going to be doing single phase 120 volt for this video. As we continue on, especially into like motor controls, we're going to be talking about that higher voltage and then kind of explaining that to you, okay? So let's go ahead and let's talk about this for a quick second. Like I said before, we have 120 volts in the positive range and 120 volts in the negative range. So this is a size or a sine wave, and it's moving up and down because it's alternating back and forth. Now, every cycle is actually two ups and down, or I'm sorry, one up and one down creates a cycle. That is otherwise known as a Hertz. You can see that I'm measuring it. Oops, probably should have gone a little bit more in line. Sorry about that. All right. This is a Hertz, so it's going to be one cycle. We're going to be doing one cycle 60 times a second. So that's going to be 60 Hertz per second. Now, if you go to another country, they might be running off a different Hertz rating. So that's why if you take something from America and you try to plug it in a different country or into a different plug, it might not operate, or it might operate differently. Now, why is the Hertz so important? Well, in certain applications, when we start talking about VFDs, we're actually going to take our voltage coming in and we're going to use Hertz to either increase the amount of, we're going to increase the amount of Hertz with our VFD, I'm sorry, or we're going to decrease it depending on whether we want that motor to go faster or slower. We're going to talk about motors in the future. The one bad thing about AC motors is they can't be brought down in speed by lowering the voltage. You actually have to drop the Hertz down to slow it down, or more Hertz will speed it up, okay? So the next thing I want to point out is from the center line up to the top is called our amplitude. Now again, that's if we wanted to have a higher amplitude, we would have more voltage at that source, okay? So just know that the amount from the zero up to the peak is our amplitude, and it could be going from the peak down to our peak on the bottom too is going to be that amplitude. Now, that's kind of everything that we need to know about AC voltage, just right up front. Later on, we're going to talk about it a lot more, and we're going to kind of get more used to it. You're going to be, working with some multimeters and things like that, or you're going to be, talking about things like transformers or motors, and we're going to constantly be bringing up some of the things that we've talked about. So if you ever need to reference this video, come back, we can talk about it. Just let me know, okay?